So today we're going to talk about domain and range of a function. And then at the end, I'm going to introduce you another function called piecewise function. Like the name suggests, pieces. Your function is connect each other by a bunch of pieces. So the domain of a function consists all of the x values, yes? Yeah, on your x-axis, or consists all the x values. If you want to compute the domain, you're going to start counting from left to right, always from smallest to largest. So for example, right here, the domain of that red function is start where the function starts. I don't know what the point is. I'm going to call it A. A could be any number, right? It could be 1, could be 2, and then it starts at B, right? So domain from A to B. Is AB included? Yes. Why is it included? Why do you think it's included? Because what gives it away? Yeah, it's filled, right? It's filled. So if it filled, if a circle is being filled, like a solid circle, then the x coordinate is included in the domain and also the y coordinate, but we'll talk about that later. Okay. For the range, you're looking for the y value. Sometimes they call it the output, sometimes I call it height. Right? The range is, you want to compute the range, you're going to compute from bottom to top, smallest to largest. And again, if it filled, so for example, if I looked up this function right here, if I plug into the function here, I'm going to have f of a, yes? If I plug in b into the function right, I'm going to have f of b, right? I don't know what the height is. I don't have a number for you, but abstractly, that's what it is. So here I have f of a, and here I have f of b. So the domain will be what? I'm sorry, the range will be what? From, what's the height? It go from f of a to f of b, yeah? Is f of a and f of b included? Yes, yes. So the domain go from A to B, and because AB included, we can use the bracket. And for the range is f of, let me write it up here so I don't fight for space. F of B, and it's included. We're gonna use bracket. You brackets when you see the fill points. What about open circle? Yeah, when you see a little hollow dot, open circle, hollow dot is not included. We're gonna use the parenthesis. Very good. If I spell parenthesis right. I blame autocorrect. I used to spell okay. Now I don't have to spell anymore. My phone does it for me. If you see an arrow or no circle, this corresponding to infinity or negative infinity. We'll talk about this later. Don't worry about this. I want you all to take a look at 1A on your own. You know, all you know how to read. So take a look at example 1A. Read through it fast. Pull up my notes. Okay, so you understand how to get the domain and range now? Yeah, I think we talked about this in the first day of the class, right? So B, let's talk about the domain first. Oh, domain, I think, oh yeah, that blue. Where do I start? From left to right? Where does the function start? negative infinity. The arrow mean infinity, right? So if you keep projecting it, you don't have to write this. If I keep projecting the function downward onto the x-axis, and imagine that arrow keep going forever, you always have an x values, right? So go from negative infinity up to, what does it stop? What does it stop? One, right? One. So one included? Yeah, bracket. So far so good? Yes.
Like, why is 4 in parentheses and not in brackets?
4?
On the
example. Because 4 is, yeah, I would suppose, I was think is included, right? Yeah, I think it's included. You're right. If I was me just eyeballing the graph, I would think 4 is included. But you know what? I gotta get back to you. Good point. Very good. I'm gonna talk to the course leader, right? Because I don't want you to have I don't want you to have confusion on the exam. Right? For me, I thought 4 is included. So it's go to 4. Yes.
Instead of closed bracket, like the actual bracket is included.
Included. You include the endpoints. Mm-hmm. Yeah, very good point. I gotta talk to her. Because even me, I do this. I think the same thing you do. 4 is included. Right now, just let it included. Okay, I'm gonna say it's included. Maybe she argued with me. We don't have the solid dot, but it went through 4. What about the range? Where does it start? Range is your height. Remember, it's your y value. So where does it start? Look at the y-axis. Yeah, start 0, right? Start 0 right here. You just eyeball over, right? So start 0. Is 0 included? Yes, right. And go to infinity, right? If this graph is going forever, stretch out forever, you can always find y value. At infinity, you always use parentheses, right? Because there's no exact number. Infinity is weird. There's a Netflix series. If you guys have, I'm sure you all have Netflix. It talk about infinity. It's really cool. It's really cool. One C. This is the piecewise function. This is what I'm talking about. This is piecewise function. So let's talk about the left function first. The one on the left. The domain. Where do you see it go? From where to where? To 0. Is 0 included? No. And then where does it start for the second right, for the second one? The right function, it start from 0. Is 0 included? Yes, right? And then what does it end? Infinity, right? And because they are piecewise function, you're gonna put a union. So the domain will be the union of a bunch of little functions. In this case, can I combine those two? No, you're not. Can I combine those two? Huh? No, they want function. They just compose a bunch of little ones. So the domain will be everything. Think of it, the king, and then you have a bunch of lords, right? And then he collect taxes. So so that can I combine those two little ones in terms of domain? Yeah, the union, right? Union. So so my question is that, can the 0 value be filled? Yes, right. If you look at it got filled. At the first one doesn't get filled, but then let me show you on the number line. When I'm in doubt, I always draw it out. So here's 0 in the middle. Initially, 0 was hollow. Let me put 0 a little bigger. So for the left function, it go from negative infinity to 0. I'm not allowed to touch 0. However, the second function, 0 got filled. I use blue. 0 got filled. And then move on to negative infinity. So if you look at the whole number line, what is your final answers? Everything, right? Everything, because it's got filled, right? Everything. So so final answer would be negative infinity to positive infinity. on the exam, I suggest you give me both. Now, it's not always to be possible to combine those functions like that. If you have a gap, then you can't combine. You just kind of leave it separate like that. Okay, which we're gonna see later. What about the range? Let's do the left function first. Where's it go? Yeah, 0 to infinity. And then the second function. Yeah, 2 to infinity. And I think it's kind of overlapping because as you can see here, see if I can show you without graphing it. That's the first one. And then the second one go from here to here. So overall, what is your range? Look at your highlight. Where does it go?
0.
Yeah, 0 to infinity, right? If you can call it overlapping, then just count everything. It's union, right? You count everything. I'll try my best to explain my things. I hope you understand. If you're not, you can always watch the video later. Or kind of me. If he teach better than me, I'm not gonna be jealous about. He's awesome. Help me through my undergrads. Now, so that is when I give you the picture, you tell me range and domain. What if I don't give you the picture? What if I give you a function instead? So that would be objective 2, right? Looking at the function, can you tell me the domain? The first function we're going to talk about is polynomials. What is polynomial function? Well, polynomial function has the form like this. Oopsie. A little bigger. F of a equal a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. I know those letters hurt your head. Just a is your what? A is your coefficient. It's just a number, right? X is x, is your variable, right? N is your power. So for example, if I start at say f of x equal 2x cubed. So q is your power, is your n, right? And 2 is just any a really, a1, a2, a3. You can make up any number for a. And then what's the next one? X what? X squared, right? X squared. And you want to be fancy, you can put a number here, doesn't matter. I just make up 1. You can put -1 you like. And then what's next? I'm talking about the power of x here. That's more important to me than the coefficient. X to the first, right? Usually we don't write first power. And then what? X to the 0, which is a constant, right? Just 1, right? Or a lot of time I just write a sub naught, right? It could be any number. By the way, polynomial function is the function that you already know. These are linear functions, the polynomial, quadratics are polynomial, cubic, quartic, quintic, right? They all polynomial. As long as you have a something to the power, that's your to the positive power, that's your polynomial. Okay. And one cool thing about polynomial function is that their domain is all real number. Think about it. If you graph like y equal x squared, y equal x cubed, the domains go on forever, right? What's the domain of the first function? Yeah, right. If you graph that linear function, it goes from negative infinity to positive infinity. What about D? Y equal 5. What's y equal 5 look like? Yeah, all remember, right? If you doubt yourself, graph it out. Graph it out. So y equal 5 is like that. If you project things down, you always find an x value. So negative infinity to positive infinity. What about C? Is it a polynomial? Like Mimi, I see fraction. Make me nervous. But is it a polynomial? Yes, right? You can split it. You can split it. If I split it, what do I have? I have negative 1/2 x cubed. I have 3/2 x. I have -1, right? It's a polynomial. In this case, you have, I don't say, you can argue me, I don't see x squared. Why don't I see x squared? I can write x squared like this. Remember, a's can be anything, right? Right, so you have x squared, you just have a coefficient of 0, so you don't see it there. So yes, it's a polynomial, so domain will be everything. So far, so good. Yes. No. A coefficient can be any real number. It can be pi if you want. And it's very insignificant. What's significant is these guy. So remember, domain of the polynomial is all real number, right? The set of all real number. Now, the second type of function I'm going to talk about is the rational function. Rational, racial, what do you think of? Fraction, I think it's fraction, right? So like the name suggests, you're going to have a function that has a polynomial divided by another polynomial. So you have f of x divided by g of x, and they call that is r of x altogether. The domain of the rational function is that as long as the denominator cannot be 0. That's it. Which just makes sense, right? You can divide it by 0. So for example, you take a look at example A. I want to find the domain of f of x equal 4x plus 2 over x plus 4, x minus 2. All you have to do is set the denominator equals to 0, and then at the end you say it cannot be 0. And then from there you come up with your interval notation. Let's do C. Let's do 3C first before I jump to 3B. Let's do 3C first. Let's see if I have any you try for you. Let's do 3C first. What is the domain here? Yeah, x cannot be what? So let me do it slowly. X minus 4 cannot be 0, and x minus 5 cannot be 0. So x cannot be 4, x cannot be 5. Don't stop it right there. You're gonna write it in interval notation. And if you're not good at doing things in your head, I don't. I'm very visual, like most people. You can draw it out. I don't care about the tick mark. As long as you put the smaller on the left, larger on the right, you're okay. The 4 and the 5 won't be included, so just cross that out. So what's my interval here? If you eyeball that, here to here, right? Here to here, here to here. So from -infinity to 4, we use parentheses because if 4 is not included. Union, all the number between 4 and 5. Union 5 to infinity. So far, so good. A lot of time people kind of ignore the decimal between the counting number, but we talk about real numbers, so we're gonna count everything. Let's do B. Let's do 3B now. It should be easy. What is my domain? Very good. X cannot be 0. So the only thing I see here, the only denominator I see here is x squared, right? So x squared cannot be 0. If you square both sides, what happened? Oh, plus minus 0 is still 0. Yes.
Wait, can we simplify the interval notation for C to -infinity?
No, because Yeah, yeah. 4, 5 is not included. So you solve this, so x equals 0, plus minus 0, still 0. Or rather, x cannot be 0. Can someone tell me what's the domain here? Interval notation? Yeah, very good. Right, so the 0 is not included, just cross that out. Everything else, okay. Okay, it seems like you got good at this. And if you feel like you don't get the lecture I'm lecturing, it's not your fault. I understand. It happened to me all the time when I was in grad school. I go home and I read it again. Like, if math is frustrating. That's why like most people do not like math. Because once you don't understand, you cannot move on, right? In English, okay, move on to different subject, but not math. It's frustrating sometimes. You don't know how many years I pull out my head. D, it will be your you try. You try one for today, 113. So please write that down. You won't see this when I post a note. Don't do it now, you won't be able to. Number 4. This is the reminder. This is a reminder. Do you guys remember how to solve inequality? If an equation, that's easy, right? You factor, you set up each of the. If it equation that's easy, right? You factor, you set each of these binomial equals to 0, and then x cannot be 3, x cannot be 6, you're done, right? But for the inequality, your answer is going to be interval, not number, right? So it's involved a little bit more. Let me remind you, what do we do? When you see an inequality like this, the first step is you're going to factor them. The second step, you're going to set each of those factors equal to 0 and solve for x. They call those critical numbers. So critical numbers is just fancy way of saying that at those values, the function is either 0 or undefined. In this case, 0, right? You plug in 3 and plug in 6 into the function, you get 0. But long story short, to set them equal to 0 and solve for them. Once you have the critical number, that's step 3. You're going to plug those critical numbers onto the number lines, smallest to largest. That will divide your number line into a bunch of intervals. If you have 2 critical numbers, how many intervals you expect to have? 3. If you have 3 critical numbers, you expect to have 4 intervals. So the number of interval will be 1 more than the number of critical numbers. So let me recap. Factor. Once you factor them, solve for x. Once you have x, draw on the number line, okay? And then we'll go from there. All right, and I'll show you how I'll do from there. So here, for example, I factor, or rather they factor into x minus 3, x minus 6. That's correspond to what? X equals 6, x equals 3, right? Once you have number 3 and number 6, you plug it onto the number line like that. 3's come before 6, the 3 smaller. And then you have 3 intervals. At the 2n, you always infinity, negative infinity. I know they don't write there, but there's negative infinity and positive infinity. Can I include the number 3 for my inequality? Should I put bracket or parenthesis at 3? Why bracket? Yeah, why bracket? Very good. Yeah, very good. Because it's the denominator, right? It's okay to have 0, and they say ratio equal to 0. So bracket, same thing with 6. That means when you plug 6 or 3 into the inequality, it's 0, and it's okay because of this. Once you have the interval, what do? You're going to pick. You're going to pick the test point. So for example, between negative infinity to 3, for me, if I go from negative to positive, my favorite number is 0. And I suggest you do the same, which is easier for your computation, right? You can pick 1 if you like, you can pick 2, you can pick negative 5, but I like 0. From 3 to 6, either 4 or 5. You want to be fancy, you can pick decimal. I don't know why you do that. Pick something easy, right? From 6 to infinity, you can pick either 7, 8, 9, or 10, or 11, or 100 if you want, right? But pick a number that fall in that interval, right? Once you have test point, the red point, you're going to plug into the original equation, or rather inequality, I'm sorry. When I plug 0 into the very first inequality, what do I get? 0. 9 times 0 is 0, right? So I got 18. Is 18 is greater equal to 0? Is it true or false? Yeah, it's greater than, right? So 18 is positive. By the way, I don't care about the number 18, but all I care is the positive. All I care is the positive. So this interval here is positive. What about the middle interval? When I plug in 4, what do I get? If it's easier for you, you can plug it in here. 4 minus 3 is 1. And then 4 minus 6 is negative 2. So negative 2, positive times negative is negative. Again, I don't care about the number. I care about the signs. So negative. And then when you plug in 10, that's math. You can do, that's positive. What interval do I want? Do I want positive intervals or do I want negative? Positive because of that, right? So that is the step. I hope you remember. This is recalling. If you don't, please review. I cannot do everything for you. If I have time, I would. Just, I'm always behind. Do you have any questions solving inequality? So far, so good? All right. I'm so sorry. It's so much information. Today, another function I want to talk about is the radical function. Radical means what? Root, right? Radical root. So if you think of root, here is the function where n is the index and f of x is your radicand. I suggest you remember what those names are. When I say index, you know what I'm talking about. When I say radicand, you know what I'm talking about. Right? Square root index is 2. We usually don't write it. It's just, I don't know, conventional. They never write it. It's kind of like, 2 over 1. We don't really write the 1. Right? Here's the domain for the radical function. If n is odd, odd index is easy going. The domain will be all real number. If n is odd, your domain will be all real number. If n is even, see if I can find another color. Then a bit trickier. The domain will be, at least the domain will be from 0 to infinity. And that's general, okay? It can be changed. Well, odd never change, but even can be changed. I don't want to write this. Delete that last part. It just remember the whatever under the radical, it cannot be negative. For example, I have y equals square root of 2x minus 4. Is it even index 2, right? So what do you have to do? Whatever under the radical, which is 2x minus 4, you have to set it. You have to set it at least 0, right? And then you solve for x. So that means x has to be at least 2. Makes sense, right? If you put 1 in there, 2 times 1 is 2. 2 minus 4 is negative 2. Negative 2 is, what's square root of negative 2? I think, right? But right now we only deal with what? Real, right? Real numbers. So I is a different thing. I that's complex. We only deal with real numbers.
So you could do this cube root of the negative.
Yes, if your instructor include the complex set. But right now, no, I'm not talking about that. So up to now, we only deal with real number. I is a different thing. That's why when we talk about real number, you cannot have negative under an even root, not just square root, 4 root, 6 root, 8 root. As long as it's even, you cannot have negative underneath. All right, all that talk. Why don't you tell me what's domain applied B? Even or odd? So what do? Everything, right? Odds are easy going. That's very easy. I don't care what it is underneath. I see odd index. Automatically, I wrote that. Same thing with what? 5D, right? Odd. All right. What about C? Huh? C. It's even, right? Even. So what do I have to do? Set the radicand, which is x squared minus 9x plus 18. Set it equal, greater equal to 0, right? Cannot be negative. Can I factor this? Can someone factor this for me? Very good. Everybody see that? Right, two number multiplies 18, which is negative 3 times negative 6 is 18, and add to negative 9. Negative 3 plus negative 6 is negative 9. Once you have that, what do you remember what I say? You said what? You said each of the binomial equal to 0, right? And then you solve for x. Once you have x, what do? You plug into your number line, right? I think we did this before. I feel a little deja vu. Yeah, we did. We just did that. But I'll walk you through this. Like still, plug 3 here and 4 here. I would suggest you draw your parenthesis or bracket, right? Here because I it's okay for me to include 3 or include 4. So I'm gonna put bracket at 3 and 4. What the next step? Huh? Oh, 6. I'm sorry. I was thinking about the test value. Thank you very much. Sorry. What the next step? Do you remember? What's the next step? Test value, right? TP, test value. Test value. Here I'm gonna pick 0. Here I'm gonna pick 5. Just a little bit different than the other one. Here I'm gonna pick 100. When I'll pick something different. I'll pick 1 because they already picked 0. When I plug in 1 into the original, when I say the original, for me it's easier for me to plug it in here. But if you want, you can plug it in here if you like. It doesn't matter. I'll use the second one because it's easier. 1 minus 3 is negative, right? Negative. 1 minus 6 is negative. So negative times negative is positive. What about the 5? 5 minus 3 is positive. 5 minus 6 is negative. So positive times negative is negative. 100 minus 3, positive. 100 minus 6, positive. 2 positive multiplied together is positive. And then we have the answer like we had before, right? So your answer is going to be all the positive intervals. So negative infinity to 3, bracket union 6 to infinity. Do you guys feel a little bit better? It's long. I know it's long. If they would allow you to use graphing calculator, I would have showed you how to check your answer on it, but they don't. Okay. Yes.
So on the exam,
Mhm.
like positive, and then I know the next one's gonna be negative.
Yeah, for a lot of cases, it'd be like that. It's like alternating, but not always. Not always. Yeah. Especially when you have a multiplicity of two. Meaning, when I say for example, this problem, it won't alternate because of the square. Right? But for most cases, yes, it's alternate. Or when you have something like this. If I have a denominator, then it might not be alternating. Yeah. So I suggest you do test point just to be safe. Yes.
Like signs,
Yeah, determine the signs.
but we didn't use the middle sign, which was natural argument, so why do you have to use that?
Your question is, why don't we pick the middle?
Like, the middle is like the negative one, but we didn't even include it, so
Why don't we include it?
Yeah.
Because what is your constriction? What is your
No,
restriction?
no.
Yeah, we want positive under the
So
root.
if it was positive, would we include it, or would we combine
Yes, we combine that.
it?
Yeah. We're talking about combine. Here's your combine. Find the domain of combined function. Well, this is combined function. It's gonna combine between what? We talk about polynomial. We talk about fraction, rational fraction. We talk about radical. Here you're gonna see all three at once. And it's getting a little bit more complicated. As long as you got your math, your basic math okay, it should be okay. If your combined function, if they are polynomial in the numerator, don't do anything. What's the domain of polynomial function? All real number, right? All real number. So if a polynomial on the numerator, then you should be okay. If the polynomial is in the denominator, what do I have to do? You factor it and set it equal to 0, right? And then solve for x, and then you say that x cannot be whatever number you solve, right? We've done that. If the square root function is in the numerator, what do? We just did it right here. The square root is in the numerator. Why was Mimi? I don't see numerator. Why I can put over 1, right? Remember, we don't ever do that. But whenever you see something that have no denominator, imagine it's over 1. Okay? So if the radical is in the numerator, you set whatever under the root they call radicand to be greater or equal to 0 and solve, like we did here, the long steps. Right? If the square root is in the denominator, oh, this is fun, then what do? Let me ask you, square root cannot take negative number, yes? Plus, now I'm gonna push down the denominator. What else it cannot be? 0, right? So you have to set whatever inside the radicand had to be strictly what? Strictly positive. Right? So you admit the 0 as well, right? Because where the position, the location. So remember those. That's important. So for example, 6a here. Do I do anything for the x in the top? No, right? It's a polynomial, right? What about x minus 6? Is a polynomial? Yes, it is in the denominator. Yes. What do? Yeah, you say it cannot be equal to 0, and then move on to the next one. So square root of x minus 3. What do? Yes, because. Yeah. I highlight, so I'll highlight that so you know what I'm talking about. There. Maybe we do one more and then we call that a day. I'll tell you what, it's a long lecture. I don't so let's do this and I'll tell you what I'm gonna do next. All right, 6b, what should I do? What about square root of x minus 3 on the top? What do I set it equal to? Oh, this should be a black, not yellow. Yes, it will be the yellow, right? This will be the yellows because the square root is on the numerator. So I had to set x minus 3 equal greater or equal to 0. Can you solve for x? Yeah. It's easy to solve inequality if your function is linear, right? If it's quadratic, then you have to do the long thing. Yay, done. What about x minus 6 in the bottom? Because in the bottom, you said x minus 6 cannot be equal to 0, right? X cannot be 6. So what is your final answer? Let's see. X is greater than or equal to 3. Is 3 included?
Yes.
Yeah, so solid dot on 3. And then you highlight from 3 to infinity. And then what else? What else? X cannot be 6. So what do you have to do to the 6? You take it out. Right? So it's become hollow now. It's become hollow. So if you look at the picture, what is your domain from left to right? From left, it start at 3 bracket, right? Go to, no, you cannot include 6. So you go to 6, and then what do you bracket or parenthesis? Parenthesis, because you do not want to include 6. And then because there are 2 intervals, so you do union, right? And then what do you start again? Yes, and 6. Very good, to infinity. So pictures help. This picture really help. No, the parentheses indicate that you do not include 6. Right? You get very close to it from the left or the right. From the left, I'm gonna get close to what? 5.99999, right? And then I skip the 6, and then I jump and I go to like 6.00001, something like that, right? So close to it, but never quite at it. Hence the parenthesis. All right, let me tell you what I'm gonna do. Your U try number 2 for today is number 8, 8A and 8B. Try, I keep saying plural. You try to January 13, which is today. That will be B and A. All right. What I'm going to do is this. I'm going to make a video about this at home. You're supposed to watch it during the weekend, okay? So next time we just start the next refresh lecture. All right. I'll send out email to you. Okay. Thank you. Have a great weekend. I'll see you Monday. Oh no, I'm sorry. Yeah, we don't have class on Monday. MLK. So Wednesday, I'll see you back on Wednesday.